is a solution. And I have two possibilities. Let me call this polynomial p of x or f of x, function f of x. Let's say f of x. Right. So one option is to show that f of 3 is 0. The other option would be to put 3 in the box, put 1, 5, negative 17, and negative 21, and show that the remainder is 0. So let's do this. So we copy 1. 3 times 1 is 3. Perform the operations I see, 8. 3 times 8 is 24. Perform the operations I see. I get a 7. 3 times 7 is 21, exactly as expected, and I get 0. So then x equals 3 is a solution, for sure. Number 1, we looked at the graph, and it crosses the x-axis when x equals 3. And the second thing is we use the synthetic division to divide by x minus 3. In other words, I'm saying that f of x divided by x minus 3 has a remainder of 0. And I show that with synthetic division. Very good question. Thank you. Anything else that you would like to go back to? Other questions? Anything you tried? Anything you want to work on? I recommend for the test on Wednesday, please come in early if you want, if you have more questions, or if you want to start early.
I tried to do number 2, and
You mean from the from
Yes.
the previous test? Yes.
for some reason,
Let's take a look at number 2. Yeah, we did it in class.
yes.
Which part you want to?
Part B, where I start at 0 on the graph and try to drag past the minimum. I don't
So
know.
with the graphing calculator?
Yes.
Yeah. So let's do that. Very good. So in y equals, we punch in the function. Don't forget parentheses around the numerator and parentheses around the denominator, mandatory. 6.5 x squared, and then minus 43.4 x plus 932, close the parenthesis, divide, open another parenthesis, x squared, and plus 144, close the parenthesis. And if you want to graph the horizontal asymptote 6.5, you have to add it in as a new function, as a second function. And now with the window, we have 0, 60 with a scale of 12. And then we have 0, 8 with a scale of 2. Do we have all this in the calculator? Yes? Okay, so now you press on graph. And here's your graph. So this is from 0 to 60 minutes. So it's coming from 6.5, decreasing dramatically, and then slowly but surely leveling off.
Okay, I think I did some.
Uh,
Oh, I didn't do the.
So parentheses, if you don't put parentheses, it will not divide by the entire quantity. It will only divide by x squared. Always remember rational functions. Is this what all you needed?
Yes.
Anything else? Other questions? Anyone? Number 8? Yes. Okay, so we have x minus 6 squared plus y plus 8 squared equals 100. X minus 6 squared plus y plus 8 squared, everything equals 100. Oh, I was looking at.
I was looking at. I was like. Wait,
I was
am
looking at
reading this
9.
wrong?
Yeah. So the I'm sorry, h of x equals the 7th root of x to the 6 minus 3 inner function. There is more than one correct answer. I will consider this the inner function, x to the 6 minus 3. And I will consider the outer function the 7th root of x. Sorry about that. I was looking at 9 for some reason. No reason.
So that's all. That's
The
it?
inner and the outer, the function decomposition. Yes, please also look at the problems that we did in class for more explanation, right? Anything else?
I have a question.
Yes.
Wait, I have it right here. This distance and midpoints are going to be on the test, right?
Yes.
Okay. So I have a question. I have maybe I already did it. Okay, I'll give you the problem.
Yes.
It's in parentheses 4 in the square root of 2, comma, square root of 5.
Oh, so that's 4 the square root of 2, comma, the square root of 5. Very good.
And then negative square root of 2, and comma 5 square root of 5.
Good. Very good. So we want to determine the midpoint?
So it was find the distance.
Okay, let's find the distance.
I did something wrong.
Very good. So let's find the distance. So the distance formula is the square root x2 minus x1 squared plus y2 minus y1 squared. And I will label them. So this is my x1, y1, and this is my x2, y2. So my x2 will be negative the square root of 2. My x1 will be 4 the square root of 2. Y2, 5 the square root of 5, and the square root of 5. So far, so good?
Yes.
Good. So now let's do this together. Negative an apple minus 4 apples.
Negative.
5 the square root of 2 squared. Is this okay?
Oh, I see what I did wrong.
Plus 5 apples minus 1 apple is 4 apples squared. Is this okay? Negative 1 apple minus 4 apples. It's minus 5 apples. 5 apples minus 1 apple is 4. So then I squared negative 5 and I get 25. I squared the square root of 2 and I get 2. Plus I square 4, I get 16. I square 5, I get 5. The square root of 5, I get 5. So this is the square root of 50 plus 80, which is the square root of 130, and no one can simplify this. Is this okay?
So why would she ask that question? That was on the homework and I couldn't understand it, and I forgot about it until now.
It was just this one that I kind of
Good.
didn't.
Anything else?
Let me break this.
Anything else? Do we have other questions?
We're learning something new today, right?
Yes, I have no choice. We're down to eight meetings and 3 chapters.
Can we do number 5B?
Yes. 5B. Yes, we have to, so here's the graph, right? So you want to determine this piece, which is the x-intercept. So you have to set y equal to 0. So negative 0.4 x squared plus 2.1 x plus 7 equals 0. You multiply both sides by negative 1, 0.4. I will multiply by negative 10 to be honest, and get 4x squared plus 21x plus 70 equals 0. Of course, I'm trying to finish quickly so I can get to chapter 4, and I'm rushing. No excuse. So I multiply both sides by negative 10. This times negative 10, 2.1 x times negative 10, and then 7 times negative 10. And then you use the quadratic formula. 21 plus or minus 21 squared minus 4ac, 4 times 4 times 70 divided by 8. Is that good enough?
I just didn't like that beginning because I thought that it was changed, so I didn't make y 0, but then like I was like,
Yes, yes, we have to make y equals 0, yes. So we can find the x-intercept. Is there anything else that we need to go back and review? Is that good enough?
That's for right now.
Anything else? Again, I recommend please come in early if you have questions or if you want to start early on Wednesday. Anything else? Is there anything else that you can think of? Okay. I can stop anytime if you remember something. Of course, this chapter is not going to be on the test on Wednesday. Obviously, it's going to be on the third test. Okay. In chapter 4, as I promised, 2 more functions, the last 2 functions for this semester, exponential and logarithmic functions. Why? Why do we need more functions? Don't we have enough? Rational, radical, absolute value, polynomial, what else? We looked at polynomial, we looked at rational with radical functions, absolute value, right? So why more functions? Well, actually, these 2 functions have a totally different variety of real-life situations or real-life applications. Something that cannot be modeled by other functions that we looked at. Which function models this? When I throw a ball up in the air, which function has this trajectory? Quadratic, very good. Then we looked at another function that was rational, in which we were giving or injecting the patient with whatever medicine the patient needed, and we were calculating or determining the concentration of the medicine in the patient's bloodstream with a rational function. Then we had that life expectancy, if you remember, with the terms, right? It was a polynomial function. Which polynomial function we will fit such and such? Radical functions. Do you remember that example with the heights of babies, either girls or boys, from 0 months till 60 months? Do you remember the radical function with their height? Right? So every function has different applications. What are the applications for these? Very important applications. For example, whenever we take out a loan for anything, if it's a mortgage or a car or anything else, our monthly payments will be calculated using an exponential function. If we are looking into a growth of populations, rats, fish, birds, mice, rabbits, they're all modeled with exponential functions. If you take a turkey out of the oven or you put it on the kitchen counter, it decreases the temperature in time, of course, right? It decreases the temperature using the log function. How do they model the earthquakes? Using the log function. What about the radioactive substances? They decrease their mass in time using an exponential function. So the applications here are tremendous. Okay, so what do? Like we always did. We look at the function, we use transformations on it, we understand the graph, we look at the domain and range of graph different shapes, and then applications. What do we do with the log? Again, the same thing. We graph, we discuss what it is, increasing, decreasing, one-to-one, function, inverse function, graphing, transformations, and then applications. Okay. Now, final question before we start. Why do you think that the exponential and the log functions are clustered together in this chapter? Just a wild guess. You may not be thinking about it. Because they are. Because they are. ... of each other.
Opposite?
We never talked about opposite functions. We talked about
inverse.
Excellent. Excellent. They are inverses of each other. That's why we study them together. Excellent point. Great job. Good. So let's talk about exponential 4.1. Function. Okay, what is this function called?
Absolutely.
Why? Because it has
The
absolute value. Why is this called what? Square root. Why? Because it has a square root. How is this function called? We graphed it. It's in section 3.5. It has something special, right? What does it have? And that's why the name. Say it again. Of course. Of course it's a rational function because it has a ratio. And it has x in the denominator. Now, how do you think this looks like? And why is it called exponential?
It's going to have exponent.
Right. Furthermore, the variable is the exponent. A is the base, which is a constant. However, the base is restricted. The number that is the base of the exponential function can only be one of the two. It can be a large number greater than 1, or it can be a number between 0 and 1. And now you should be appalled, right? And you should say, wait a minute.
This is similar.
You should say, that's not true. I can take negative 3 to the 4th power. I don't see a possibility for a negative base. I can take 1 to the 3rd power. I can take 0 to the 5th. How come that these are excluded? 1 is not anywhere. 0 is now nowhere to be found. And a negative number as the base is not acceptable. So all these are not possible when it comes to exponential function. Why? Here's the only reason. This function will not exist if we allow the base here to be any of these numbers. The inverse function will not exist. So therefore, we have only two possibilities. Either a positive number greater than 1 for the base. I'm not talking about the domain of the function. I'm talking about the base of the exponential function. So here would be two possible examples. 2 to the x, and the other possible example is 1/2 to the x. You see that 2 to the x fits the first category, where the base is a number greater than 1, and 1/2 to the x fits the second category, because the base is a number between 0 and 1.
Could you say that one more time? Sorry.
The base is 2, which is this category greater than 1, and the base is 1/2, which is this category between 0 and 1.
Okay.
Is that clear, everyone? Okay. Obviously, this function will have two different shapes. When the base is greater than 1, it will look in a certain way. When the base is less than 1, it will look in a different way. Ready to look at the graph? Okay, let's do that. So let's continue with 2 to the x. Just look at the graph. What do we have to do when we are asked to graph a function? What is the first thought? Excellent. Excellent. Can anyone give us the domain of this function? We're not talking about the restrictions on the base. We're talking about this, what this power can be.
Negative, well, no.
It can be negative. I can take 2 to negative 3. It can be 0. I can take 2 to 0. And it can be 5. I can take 2 to the 5th. So then what is the domain of this function? Exactly. It's a friendly function. Friendly. No restrictions. A nice function. Quote unquote. Friendly. Good. So let's pick some numbers like -2, -1, 0, 1, and 2. Well, let's take a moment and plug in -2 and get 2 to -2, plug in -1, and so on and so forth. So how much is 2 raised to -2?
Negative.
Did not say a negative number. The power does not make the number negative.
You said -2 raised to the second power.
2 -2 cannot be the base. The base of this exponential function is clearly 2. So we want to raise 2 to -2, which is 1 over 2 squared, which is 1/4. So please try to get used to a negative exponent being a fraction. We have to understand this. So 2 raised to -2 is 1 over 2 squared, which is 1/4. What about 2 to -1? 1/2 indeed, very good. So let's plug in 0, 2 raised to 0. 1, very good. Please remember, a raised to 0 is always 1 as long as a is not 0. And of course, the base is not 0. The base is 2. Very good. So 2 raised to the first power. And 2 raised to the second power. Very good. Now I would like to determine the end behavior. Let's go this way. 1, 2, 4, 8, 16, 32, 64, 128. Where am I going? Say it again. Towards? Perfect. Excellent. I just didn't hear it. Sorry. The other side. 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, 1 over 64, 1 over 128, 1 over 10,000. Careful. They're all positive numbers. There's no negative here. 1 over 10,000 cannot give us a negative number. Is that clear? 1 is positive, 10,000 is positive. There's no discussion about negative, right? So I have 1 cake, and I want to send it, I want to share it with 10,000 people. When I get to you, how much will you get out of it? I have 1 cake, I'm sharing it with 10,000 people. How much will you get?
One.
Will you even taste it? So how much will you get? 0. Exactly. 0. Nothing. Which means y equals 0, horizontal asymptote at -infinity only, not at positive infinity. We have never seen this before. So here's how the function looks like. The horizontal asymptote at -infinity and infinity at the other end. Let's graph it. This is totally new. We've never seen this before. So, from left to right, please dictate the first ordered pair.
Left to right. -2.
Excellent. Next ordered pair.
-1.
Excellent. Next ordered pair. Excellent. And 1, 2. And here's the graph as expected. This is the graph of 2 to the x. What can you say about this function? Oh, I can talk about this function for 5 minutes. Here's what I can say about it. Domain, all real numbers. Range, please.
All real numbers. Well,
Careful.
I mean,
0 to infinity, indeed. 0 to infinity. The range of this function is 0 to infinity. Is it increasing? Yes, on all its domain, completely always increasing from left to right, correct? As x increases, y will always increase. Agreed? Is it 1-to-1? By the
Yes. But the test.
by the
Horizontal.
horizontal line test is 1-to-1. Does it have an inverse function? Yes, because it's 1-to-1. I want to graph it. Remember, we always have to plot or graph y equals x when we graph the function and the inverse on the same coordinate system. So look at the ordered pairs and give me few so I can graph. I need to graph the inverse function.
1/4 and 2, -2. Can you do it?
I cannot pick and choose. I have to look at what I have.
Well, yeah, 1/4
Yes?
and -2.
Excellent. 1/4, -2. Great job.
1/2 and -1.
Excellent.
How many you need?
A few more. 2 more.
2 and 1 and 4 and 2.
But this is crucial.
Oh, well, okay.
Very good. Awesome. Well done. This is the inverse function of that. We will name it in a minute. Let's establish something. If the exponential function has domain, one more time. Friendly. And range. Excellent. This function, whatever it is, I'm going to name it now. It's log. I'm going to get back to it, but I want to establish this from the very beginning. What is the domain of this log? As the inverse function of the exponential. Exactly. It has to be this. That's why we reversed. You gave me the reversed. If you gave me the reversed, then of course this is the domain and this is the range, right? We know that. That's what happens to the function and the inverse, right? If the function takes 1 to 5, the inverse function will take 5 to 1. Is that clear?
Say it again. If the inverse.
That's how you reverse the coordinates for me.
Right.
So this must be the domain now. You reverse the coordinates, right? So this must be the domain for the log. This is what we discussed in the previous chapter, right? This will be the domain and this will be the range because they are reversed now. If the function takes 2 to 5, the inverse function must take 5 back to 2. That's how the inverse function works, right? Right? Do we agree? So the exponential function is defined on all real numbers and the range is 0 to infinity. It must be reversed for the log. For the inverse function, look at this function. Is it clear that it's defined on 0 to infinity? There is nothing on this side. It's defined on 0 to infinity, correct? What is the range of this function? Everything. From negative infinity to positive infinity.
I have a question.
Yes?
The range for the original, the two,
To do the x
The
exponential,
is 0 and infinity.
0 to infinity, correct.
0 to infinity. Why again?
Because it doesn't,
The lowest.
the lowest function value is here, but it's not attainable. It's a horizontal asymptote. So it's from 0 to infinity. 0, 0 to infinity. This is a domain, negative infinity to infinity, that's for x. And for y, from 0 to infinity. Is that okay?
Kind of.
But that's what we have. This is the end behavior.
Right, but where we get the 0 from?
1 over 2, 1 over 4, 1 over 10,000, 1 over 10 million, 1 over 10 billion, 1 over 100,000 billion. It's 0.
Okay.
1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, 1 over a billion.
It's just something you just need to know that it's going to be 0.
But here's my question. I have $1, and I want to share it with everyone. We're 7 billion on the planet. And I start in India, and I cut that dollar, and I cut that dollar. How much will I, when I knock on your door, how much will you get from that dollar?
I guess it's going to be 0. But what I'm saying is that just something that you should just, like,
Okay,
that should just be known, right?
okay, let's do this. I want to divide, cooperate please. I want to divide 1 by 10 billion. 10, 1, 2, 3, 1, 2, 3, 1, 2, 3. Enter. This is 0.000000000000001. You want to have that in your bank account? Nobody wants that. So how much is it? When I divided 1 by 10 billion.
0.
Right? Does
Okay.
it make sense?
Yeah.
Better?
Yep.
Very good. So therefore, the range of this function is from 0 to infinity. Therefore, the domain of this function is from 0 to infinity. Do we remember this correspondence? So if the exponential function is defined here and the range here, the log must be reversed because it's the inverse function. Is that okay? Yes?
You said if it's defined there, then meaning if it's 1-1, then we know it's
So yes, of course, that's based on the one-on-one property. I agree. So one more time. The exponential is defined here, and the range is this. The inverse function has to be this. Mandatory. You already gave me 0.14 comma -2, and I plotted it here. Then you said, which is perfect, 1/2 comma -1, and I plotted it here. So then this is the domain of the log, and this must be the range of the exponent of the log.
So the log is another word for,
The log is this green function.
okay, there we go.
It's the inverse. I named it. Okay, I'm sorry about that. I should have put it here as well. Is this okay? Better? Okay, perfect. Let's look at the other shape. So the other shape is 1/2 raised to x. Let's take a look. What is the domain of the exponential? We already called it friendly. Oh, one thing I was going to say here. Because log is defined on 0 to infinity, should we consider that friendly? It's not friendly. It has restrictions. And it will join 2 other functions that we know have restrictions that we studied before. Can anyone tell us which other functions have restrictions? That I always said, state the domain, state the domain. It's not all real numbers. It's not all real numbers. 2 other functions. No, that's friendly. 2 other functions have restrictions. Exactly. Awesome. One of them is the square root, because we cannot take the square root from a negative number. Awesome. And what is the other one? It's from the previous chapter, chapter 3. Excellent. Rational. Because they have vertical asymptotes. They're not defined everywhere. So this is another function. Log is another function that is not a friendly function. So log, the square root, and rational are all functions that need attention. We have to pay attention to them. Good. So one more time, the domain of this exponential, or any exponential, what will be the domain? Very good. Let's pick the same numbers, and please give me the answer. Let's plug in. Let's plug in -2 and tell me what you get. Remember, the negative power only means a fraction. It does not mean a negative number. Say it again. But I have a 1/2 now.
Oh, yeah.
So it's going to be, okay, let's do this together. 1/2 raised to -2 is 1 over 1/2 to the second power, or 1 over 1/4, which is 4. So that is a fraction. It's a totally different story. You bring a fraction down, you raise it to the second power, you get 1/4, but then you have to flip the fraction because you are dividing by it. Is this okay? Let's plug in -1. What do we get when we plug in -1? Excellent. When we plug in 0? Excellent. When we plug in 1? Excellent. And then 1/4. Now I want the end behavior. Where am I going this way, please? Excellent. So y equals 0 is a horizontal asymptote at infinity now only. Now, where am I going this way? Excellent. So now, this is a different story. The previous one was looking with like this, with an increasing all the time. How will this one look like? Decreasing all the time. Very good. So let's do that. Please dictate the first ordered pair from left to right. The first. Yes, indeed. -2, 4. Excellent. Next one. -1, 2, 0, 1, 1, 1/2, and then it starts being difficult to plot. Can anyone give us the range of 1/2 to the x? Range. From small to large, not from large to small.
0 to infinity.
Do we all agree with 0 to infinity? Perfect. 0 to infinity. Is it 1 to 1? By the horizontal line test is 1 to 1. Is it? Does it have an inverse function? Of course. Give me a few points so I can graph the inverse. So you said 2, -1. Awesome. 2, -1 is a point. Excellent. Excellent. 1/2 1. Here's one other point. If the function crosses y equals x, so will the inverse. Because you cannot reverse this. It's the same point. Because it's x equals y. So you said 1/2 1. Here it is. So this is the inverse function of 1/2 to the x. Okay, I would like to use a transformation. Let's say we want to graph f of x equals -2 to x plus 1 plus 4. Using transformations. And then we'll look at applications of these two functions. Okay, what is the base function? What is the base function? No. Say it again. Correct. 2 to the x. Awesome. That's the base function. That is what I use to create this function. Very good. First transformation in the order of operations. First transformation on 2 to the x. And what are we changing? No, this is too far. In order of operations, I have to address x plus 1. So 2 to x plus 1. What transformation is 2 to x plus 1 on 2 to the x? I'm changing x. I'm not changing y. I'm changing x into x plus 1. Careful. Left one. Good. Number 2, negative 2 to x plus 1. What transformation is negative 2 to x plus 1 on 2 to the x plus 1? Reflection with respect to, reflect with respect to, it depends on what I'm changing. If I'm changing x, it will be with respect to the y-axis. But if I'm changing y, it will be with respect to the x-axis.
So y-axis.
No, because I'm not changing x into negative x. I'm changing y into negative y. So it's with respect to the x-axis. Very good. Is this clear? Perfect. Number 3, negative 2 to x plus 1 plus 4. What transformation is this on this? Say it again. Excellent. Up 4. Great. How do I graph to do the x? Is it increasing? Is it decreasing? How do I graph it? Say it again. Yes, because the base is greater than 1. Very good. It crosses where? At 0, 1. Always. 0, 1. The pure exponential function to do the x will always cross at 0, 1. Very good. Then you told me to move this left 1. So please give me, where does this point, this is my marker, this is my reference point, where does it go when I shift this graph to the left 1? Negative 1, 1. So here's the graph of 2 to x plus 1. Then you told me to reflect this graph with respect to the x-axis. Please tell me, where does this point go? Excellent. Here's the graph. So this is negative 2 to x plus 1. Then you told me to do what? You told me to shift everything up 4. Excellent. Can you please identify for these 3 functions, what is the horizontal asymptote? Y equals 0. Excellent. But now, when I take this purple graph and I move it up 4, where does its horizontal asymptote move? Up 4 as well. So 1, 2, 3, here it is. Y equals 4 will be the horizontal asymptote to the final graph. But now I need you to tell me, where do I move this point, my special point? Where does it move? Indeed, excellent. Here it is. This is the final graph. F of x equals negative 2 to x plus 1 plus 4, indeed. Now I'm going to ask you, what is the range of this function? The final one. From the lowest to the highest. It's the same thing. The range is always the same. What is the lowest? Negative infinity. To what? To 4, indeed. The range is negative infinity to 4. Any questions? Okay, ready for applications, but I want to mention 2 things. Special exponential functions. They're so special. One is called common exponential function, and the other one natural. Here's the notation. The base is 10, and for the other one, the base is e. let's take a look. Go to the graphing calculator, please.